Hello everyone. Today we discuss about basic diode circuit, transistor application and also JFET operation. Basically in these classes we discuss about different types of electronics devices. So first of all, the most important device in electronics, and there are lots of application using this electronics device. So first of all, it is named as PN junction diode. Okay, one thing should be remembered, that in this class or in this tutorial we only talk about the circuit operation of PN junction, not talk about the physics of semiconductors or any kind of energy band theory, only talk about the circuit application. So first lecture about PN junction, then talk about bipolar junction transistor, and third one junction field effect transistor. Okay, these three are very important and very fundamental in electronics. So first of all, we talk about PN junction diode. So this is the circuit symbol of PN junction diode. This is P type and this is N type terminal. This is the circuit symbol of PN junction diode. So the forward bias of this diode means we connect the battery positive terminal with P type end and battery negative terminal connected with the N type of the PN junction diode. So this is a forward bias connection, and if we connect in the reverse bias condition, then just opposite connection with the battery. That means battery positive terminal is connected to N side and battery negative terminal connected to P side. So this is the ideal characteristics of a PN junction diode. This is a forward bias and this is the reverse bias. Because the reverse voltage is very high, this is the reverse voltage, and this is a forward voltage, which is 0.7 for silicon and 0.3 for germanium diode. Okay, so this is also known as reverse breakdown voltage. And one thing should be remembered, that this current, forward current range is milliampere and this reverse current range is nanoampere range. Sorry, this is a nanoampere range. Okay, so this is the basic principle of PN junction diode. We don't talk about the band diagram theory or energy conduction band or valence band, just operation, just talk about the circuit operation. Okay, so now first of all we talk about diode circuit. So what is the properties of diode circuit? Basically there are two applications, common application. One is static characteristics and number two is dynamic characteristics. Okay, these two are very important for diode characteristics. So first of all, for static characteristics, what is a static characteristics? In a static characteristics, we plot diode voltage versus diode current, varying the supply voltage. Okay, and in the dynamic characteristics, we plot input supply voltage versus diode current, vary the load resistance. Here we vary the load resistance, and in this static characteristics we vary the input source terminal, input source voltage. So now for the circuitry, first of all we talk about static characteristics. So for static characteristics, first of all we take one voltage source whose magnitude equal to Vg. This is a positive and negative terminal, and we connect one potentiometer. This is a 3-terminal potentiometer. This is a middle terminal, this is a first and third terminal is grounded. So if we vary this potentiometer, then the voltage across here V input is also changes. Okay, this is the basic property of potentiometer. Everyone also bother about that. So now what is the circuit? This is called the safety resistance for diode. This is diode, and here we connect 1 milliammeter. Okay, this is a positive and negative sign, and here we connect one voltage source Vd. This is a positive and negative terminal, and here in this circuit the current is propagated, which is named as Id. Okay, this is the diode current, and in this terminal this is a grounded. Okay, so what is the meaning of RS? RS means safety resistance of the diode, because if the voltage across the diode is certainly increased, then there is a chance of to destroy this diode. So for safety purposes or to limit the current in a diode, we use this RS resistance. So how to calculate this RS value? This RS value is very important for diode circuit design. So how will we design this RS value? First of all, for to getting the value of RS, first of all we know the power wattage of the diode. In a electronics, in a practical electronics, we use the 0.25 watt diode. So basically these are 0.25 watt diode, and breakdown voltage in a forward bias is 0.7, and here from here we getting the value of current. Okay, from here we getting the value of current. These are watt and these are volt mode. So current, please student, please take this note carefully, because watt and these are volt. So current, please calculate the current in a milliampere mode. Okay, so you calculate this. So now what is the formula of what is the value of RMS? Because from this circuit, if we apply KVL here, then what is the formula? Then the formula is V input is equals to ID into RS plus VD, because according to KVL this voltage drop equal to this plus this. Okay, so what is the value of here RS? So RS is basically nothing but V input minus VD divided by ID. So now V input, what is the value of V input as per your requirement? So what is the value of RS? I again written here V input minus VD by ID. So V input is, say, consider 12 volt, VD equal to 0.7, and what is the value of current? This current value is getting from here, and finally we calculate this value of resistance and connect this circuit. And after finish this process, we make this circuit and vary this potentiometer. For vary this potentiometer, here the diode voltage drop also vary, and according to the diode voltage there is also vary the current. So after variation of this input voltage, this is a VD voltage and this is the ID current. The graph is look like this. This is the cut-in voltage 0.7. Practically there have some difference, either 0.6, 0.8 for different types of doping concentration in a practical industrial sector or diode manufacturing sector. Okay, so now from these characteristics, this is called the forward characteristics of a PN junction diode. Now from these characteristics, if we take any point here, then at this point we get two values. Here these are value of voltage and these are value of current, and the ratio of this voltage and current is known as RDC. That means this is known as DC resistance or static resistance, and this is also known as, and if we take delta here, changes of, that means these are delta ID changes of current, and this is delta VD. So the ratio of delta VD by delta ID, this ratio is known as RAC. That means it is also known as dynamic resistance. So these are basic diode circuits operation. In this lecture we talk about the basic diode circuit using static characteristics. Okay, so these are static characteristics of PN junction diode. Now we talk about what is the dynamic characteristics. So now we talk about the dynamic characteristics. For dynamic characteristics, we again connect this voltage source with one potentiometer. These number 1, number 2 and number 3 terminal. Here we connect one resistance, here we connect one diode, but here some changes. Here we connect current meter, milliammeter, and here we connect load resistance. Okay, this is RL, this is a load resistance, and this is RS safety mentioned by the previous static characteristics. This is V input. So now for dynamic characteristics, the variation of the parameter, this is Vg. What is the variation of parameter? Here first of all we fix this value RL. For any fixed value of RL, we vary V input and also record the value of current. Okay, so now for different types of RL, like 100 ohm, 200 ohm, 220 ohm, 330 ohm, different types of resistance are available in a market. So if we vary this V input, then ID will be also changes. So after variation of these dynamic characteristics, this axis we plot V input in the x-axis, and the y-axis we plot diode current, and here we get 3 value of current. Say consider, because we take three different value of resistance, RL1, RL2 and RL3, and here the condition is that RL1 is less than RL2 is less than RL3. Why? Because if we increase the value of resistance, then the magnitude of the current is also decreases. Okay, and also we calculate the current formula according to the KVL from this circuit. So according to the KVL from this circuit, what is the equation? V input equals to, because in this circuit the current equal to ID, so this V input equals to this drop plus this drop plus this drop. So ID into RS plus VD plus ID into RL. So what is the value from here? ID equal to V input minus VD divided by RS plus RL. This is a very important formula. So now here we see that if we value this load resistance, the magnitude of the load resistance increases, then this magnitude of current is also decreases. So this is the basic nature of the voltage current relationship, or the concept of Ohm's law. Okay, this is a basic property of Ohm's law, because you already know that V equals to IR. So basically I equals to V by R. So this is very fundamental. So if we increase the value of resistance, then the current also decreases, and vice versa. If the resistance value decreases, then the current also increases. Okay, so this is the basic property of any electrical circuit or electronic circuit. Okay, so now, so from this concept, one thing also discuss, that is in a static characteristics. From the static characteristics, what is the value of current? The value of current is Vs minus, or sorry, this is, we consider here V input. So this is V input minus Vd divided by Rs. And what is for dynamic characteristics? For the dynamic characteristics, we got the value Rs plus RL. Okay, so this is for from the dynamic characteristics. So from the static characteristics, the characteristics look like that. This is Vd and this is Id. This is the static characteristics. Sorry, this is the static characteristics. Okay, of the diode. This is in the y-axis we plot, in the y-axis. Sorry, just a minute. In the y-axis we plot current, and in the x-axis we plot diode voltage. In this axis we plot diode voltage, and in this axis we plot diode current. I stands for current, which is denoted by IT. So now we draw the load line concept. So what is the load line first of all? So taking this equation, from this equation we use this equation. So from this equation there are two conditions arises. How will we get? Will we get that? First of all, for case 1 there are two cases, and case 2, sorry, I write here case 2. First cases is when Vd equal to 0, that is diode is short circuited. So what is the value of current? Current is V input minus Rs. This is the current. And in the case 2, Id equal to 0. So for Id equal to 0, that means V input equal to Vd. From this equation, this is a very simple equation. So this is Id. So now when this V input is maximum, that means when V input is maximum, then the current value is 0. So 1 point here. So what is the coordinate here? The coordinate is, sorry, the coordinate is V input comma 0, because this is x maximum, y minimum, and in the x-axis is just reverse, because here voltage is minimum and current is maximum, that is V input by Rs. This is known as also the maximum current. So we just connect these 2 points and we getting the line. This is known as load line. This load line select, or this load line determine how diode will be operate in a cutoff mode, or in a normal operation mode, or conducting mode. So one point is very important, that the point where, I again repeat, the point where this load line intersect this characteristics curve, that means this point is known as quotient point or Q point. This Q point is very important for designing the circuit, because for selection of the Q point we consider that how much current in the diode will be conducting, because if this Q point is situated in the lower part of this graph, that means the magnitude of the current, or the current magnitude which is conducting to the diode is minimum, and if the Q point is located in the upper portion, then the diode current will be maximum. but they have some certain point of this Q point, because below this threshold level the diode is on off state, and below this point the diode there is a large amount of current is flows through the diode, so the diode will be damaged. So that is a very important point to study the proper Q point values for different types of circuit design as per application or as per requirement. Okay, so this is the basic static characteristics and dynamic characteristics for a PN junction diode, and this is very fundamental for electronics. Okay, in the next lecture we discuss about the different types of application using diode, like a clipper circuit. This clipper circuit, one application of this clipper circuit is known as rectification or rectification. Another important part is clamper circuit. Okay, this is very important, clamper circuit. Clamper circuit also known as voltage doubler circuit. This is very important, voltage doubler circuit. So there are lots of rectifier available, like a half wave rectifier, full wave rectifier, bridge rectifier. So rectifier is a device which convert AC to DC voltage. Okay, so there are lots of application using diode, and using diode we also design signal shaping circuit. These applications are studied in instrumentation. There is an instrumentation part in electronics where we study about these lots of concept of diode, how the signal will be clipped or how the signal will be shaped from one signal pattern to another signal pattern. So first of all, clipper is a very interesting thing. So there are basically two clippers are available. In this lecture we only talk about the concept of clipper. So there are basically two different types of clipper are available. One is positive clipper and another is negative clipper. So first of all, consider these AC source, and here we connect one resistance and here we connect one diode. So suppose these are safety resistance. So what is the voltage from here? So this is a very interesting. This is a sine wave periodic cycle. This is the AC input source. The magnitude is Vm. First of all, it is remembered that this is not AC main supply. Okay, this is not a 220 volt. This is AC source from the signal generator. Okay, we connect signal generator here, not AC main voltage, because here diode is 0.7 and resistance is a very low value. Okay, we only connect here signal generator or AC generator, and suppose the peak to peak value is 10 volt. Okay, 10 volt peak to peak, that means amplitude 5 volt and 5 volt. 5 volt in a positive side, that means here 5 volt in a positive side and 5 volt in a negative side. So what is the diagram here? This is very interesting. So this is our input. So what will be the output? These are first T/2 cycle. This is T, complete amplitude. So now analyze this. So for in the positive half cycle, the diode is conducting. I again repeat, in the positive half cycle the diode is conducting. So what is the voltage? 0.7. So 0.7 is a very low voltage, that's why it is a very low voltage shown here. And the negative half, diode is open circuited because reverse bias, so we get full negative voltage here. And again in the positive half cycle we don't get any output because 0.7, we again get this negative in the negative half cycle. So basically this diode is clipped in the positive part of the signal. Please note that this is the clip the positive part only, not negative part. That's why it is known as positive clipper. So what is the design of this negative clipper? It's a very easy, because just we replace the position of resistance and capacitance. It's a very easy. Sorry, this is V0. Now this is the input cycle. Okay, I again repeat one cycle. So in the positive half cycle the diode is conducting and there is a current flow, and this I into R, that means here voltage drop is created. But in the reverse bias there is no current because the diode is reverse biased. The diode is non-conducting, there is no current, that means current equal to 0, so voltage drop equal to 0. So that means this circuit clips the negative part of the signal, of the input signal. These input signal, and these output signal. This is here the output signal, this is also the input signal. So that's why this circuit is known as, this circuit is also known as a negative clipper circuit. This is very, very important. Okay, and this principle is applied in the rectifier circuitry. So that's all for today. In the next lecture we discuss about the different types of different types of electronic devices, like a clamper circuit, rectifier circuit, and also study bipolar junction transistor. And in the later lecture, in the later part, we discuss, in the last session we will discuss about junction field effect transistor and its concept and circuit and design.